we will start our discussion on Unit 8. Okay, so before I proceed to the last unit, which is about the concept of probability, I want to revise some of the points that we have seen in the previous unit. Okay, so I will give you a short summary about what we did before. So, as you all remember, the previous unit was about solid figures and measurements. And in that unit, we have seen 4 different types of solid figure, and we have seen their properties. Then after, we discussed how we can measure the different quantities associated with solid figure. Okay, so just to remind you some of the points, one of the type of solid figure that we have seen is about prisms. Okay, it was about prism. The second one was about cylinders. The third one was about cone. And lastly, we've seen pyramids. Okay, so we defined what these solid figures are, and we calculated the different measurements for each of these 4 solid figures. Just to give you a short summary on the measurements, for example, if you see the prism, in prism we have seen how we can calculate the lateral surface area of a prism. Since a prism contains polygonal bases, you can consider the perimeter of the base times the height. Okay, so the lateral surface area of a prism is defined as the product of the perimeter of the base times the height. Okay, so this is the lateral surface area. The total surface area of a prism is given by the formula AT, which means total surface area. This is the sum of the lateral surface area plus 2 times area of the base. Why 2 times area of the base? Because prisms contains 2 congruent polygonal bases. Okay, and the third measurement was about volume. Okay, the volume of a prism is calculated by the formula. The volume of a prism is the product of base area times height. Okay, so calculating the base area depends on the nature of the polygonal bases. Okay, so these are the measurements in prisms. When you come to the second case, a cylinder, you all know that a cylinder is a solid figure with congruent circular bases, and we used the same thing. We calculated the lateral surface area of a cylinder, which is going to be the circumference of the base times the height. Circumference of the base times height. Since circumference is defined as 2 pi r, in place of c, you can substitute 2 pi r and multiply it by h. And the total surface area for a cylinder is the sum of the lateral surface area plus 2 times area of the base. Since the bases of a cylinder are circular, in place of AB, you can replace pi r squared, and AL is obtained from the first one. So you can rearrange this thing, and it becomes 2 pi RL plus 2 times pi r squared. Or this can be rearranged in this manner. 2 pi r times L plus R. Okay? And the volume of a cylinder is given by the formula. The volume of a cylinder is given by base area times H. Since the basis is circular, in place of AB, you can replace pi r squared, or you can substitute pi r squared. So it becomes pi r squared times H. Okay. So similarly, you can use formulas for a cone and pyramid to calculate the different measurements associated with cone. For example, if you want to calculate if you want to calculate the lateral surface area of a cone, the lateral surface area of a cone is given by half of the perimeter of the base times the slant height. Since the base is circular, in place of P, you can substitute circumference, and this becomes 2 pi r times 1 over 2 is here, times L. So this can be simplified into pi RL. Okay, this is the formula that we use to calculate the lateral surface area of a cone. The second one is the total surface area of a cone, which is the sum of the lateral surface area plus area of the base. Okay, we don't multiply base area by 2 because a cone contains a single base. So you can take this AL from here. So this result becomes pi RL plus pi R square. Okay, so you can rearrange this thing in different forms. That's up to you to use different forms. And lastly, the volume of a cone is given by the formula 1/3 of area of the base times h. Since the base is circular, it's a very simple matter to determine the area of the base, right? The last solid figure is about pyramid. So in pyramid, as you all know, it's a solid figure with triangular faces, but the base can be any polygon. So for a pyramid, you can use these formulas. The lateral surface area of a pyramid is half of the perimeter of the base times the slant height. The total surface area is the sum of the lateral surface area plus area of the base. Okay, here in these two solid figure, when you calculate the total surface area, you shouldn't multiply area of the base by 2 because both these solid figures contains a single base. So this is how you calculate the total surface area, and the volume of a pyramid is calculated by 1/3 of area of the base times h, where base area is calculated by considering the nature of the polygon. So these are shortly the measurements that we have seen in the previous unit, right? So today we proceed to the last unit, which is about probability, the concept of probability, okay? So Unit 8 is Introduction to Probability. Introduction to Probability. So under this unit, there are 3 major subtopics. The first one is the concept of probability. The second one is probability of simple events. And the third one is applications. So we will see, if we have time, we will see applications of probability in 8.3. But for today, we will be focusing on the first part, which is 8.1. 8.1. The concept of probability. So in our today's discussion under this topic, we will be focusing more on definition of terms, and I will also use examples to clarify the definitions and terms under the theory of probability. Okay, so let's see the first definition that we have in this unit. So our first definition is about experiment. Experiment. So what do we mean by experiment in probability concept? Okay, so an activity involving chances. in which results are observed. Well, the first definition that we have in this unit is about experiment. In probability, experiment is defined in this way. An activity involving a chance in which results are observed is called an experiment. Okay, so I will explain this thing using example. First, I want to list out the first three definitions which are widely used throughout the discussion of probability. So the first definition is about experiment. The next definition is about sample space. Definition 2. Sample space. Okay. So a sample space refers to the collection of all possible outcomes in an experiment. Okay? I will repeat it. A sample space is defined as the collection of all possible outcomes in an experiment. Okay? So this is the second definition. The third definition is about events. The collection of all possible outcomes in an experiment. So this is the definition of a sample space. Sometimes we call it a probability set of an experiment. Okay, I will use these two terms interchangeably, sample space and probability set of an experiment. Okay, they have the same meaning. So generally, it's a set containing all possible outcomes in the experiment. And the third definition is about event. Okay, definition 3 is about event. So an event is defined as any subset of a sample space. Okay? An event is defined as any subset of an experiment. I mean, any subset of a sample space. Well, so far, we've seen three definitions which are widely used throughout the discussion of probability. So the first one was about experiment, the second one is about sample space, and the third one is about events. So let's take a certain example to describe what these three definitions are. Okay, so if we take tossing a coin once, okay, look at the first example. Example 1. Toss a coin once. You might have played tossing a coin with your friends, or at least you might have observed tossing a coin when referees are leading a game, right? So hopefully you are familiar with tossing a coin. In tossing a coin, what is the experiment? First one is, what is the experiment? The second one is, write the sample space. Write the sample space. The third one is list list the events. Well, we have defined these three terms earlier. Here, there is an activity which is about tossing a coin. Here, the question is, what is the experiment in tossing a coin once? Here, the experiment is doing or performing a coin, okay? Just throwing a coin and observing the outcome. That is the experiment, okay? Tossing a coin is, the answer for the first part is, tossing a coin is the experiment. Tossing a coin itself. Okay? So just simply a performance or an activity that results an outcome is an experiment. So for this first example, your answer should be tossing a coin. The second one, here you are asked to write the sample space. Well, if you are asked to write the sample space, you need to consider all the possible outcomes in the activity of tossing a coin. So definitely the outcome will be head or tail. So the sample space will be a set containing head and tail, okay? So I use capital S to represent a sample space, and this sample space will contain all collections of the possible outcomes. So it can be a set containing head and tail. Or shortly, you can write it like HT, where H refers to the head and capital T refers to the tail. So we don't have any other option except head and tail, right? The third one is list the events. In our definition, we have said that an event is any subset of a sample space. So as you can see here, the sample space contains head and tail only. So our events can be a set containing one of these things. So whenever you are asked to list out the events, your answer should be a set containing H or a set containing T. Okay? In some cases, you can include both, depending on the nature of the question. So this is a simple example to clarify the three definitions that we have seen before. Now let's take another example so that you can understand the definition of terms. Let's take this one. Consider throwing a die, once. Okay, so before writing the questions, a die is a cube with different number of dots on each faces. Okay, you all know what a cube is mean from our previous discussion. So roughly a die is a cube. You can roughly assume this as a die, but there are totally 6 faces. In each of the faces, there are dot numbers, right? In one of the face, you may have 1 dot. On the other face, you may have 2 dots. On the third face, you may have 3 dots. This may not be clear, but you can assume a cube having different numbers on different faces. So that is a die. Okay, don't forget, tossing a coin and a die are the most common examples that we will be using in the discussion of probability. So here we are considering throwing a die once. Okay, so what is the sample space? The sample space The second question is, what is the event of getting a number on the upper face is odd. The third question is, what is the event of getting a number observed on the upper face is different from 4? So what is the event of getting a number on the top upper face is different from 4? Well, let me stop here. You are asked to consider throwing a die once. That means there is a certain solid figure having a shape of cube. Each of the faces contains different numbers 1 up to 6. So that is the situation. So the experiment is throwing a die once. So in this experiment, you are asked to determine the sample space. So as I've said before, a sample space is the collection of all possible outcomes. So you need to list out all the possible outcomes in the experiment. So for A part, our sample space will be a set containing numbers 1 up to 6. 1, 2, 3, 4, 5, 6. Okay, so this is the sample space. We don't have any other options. You cannot observe anything out of this. So these are the sample space. The second one is in B, we are asked to list the event of getting a number on the upper face is odd. So the favorable condition in the case of B is an event containing numbers on the top which are odd is 1, 3, 5. Okay, your event cannot be out of the elements from the sample space. So you cannot have numbers 7, 9, and so on. So our event in B case is a set containing 1, 3, 5. Clearly, this set is the subset of the sample space, and we are asked to list out the favorable condition in which the results are an odd number on the upper face. Okay, so the answer for B case is this one. The C part, in C, we are asked to list out or to write the event of getting a number on the upper face is different from 4. So you need to consider the sample space and list out a number different from 4. So the event in the statement C will be a set containing 1, 2, 3, 5, 6, because it says the favorable condition is a number different from 4. So this is how you list out. Okay, sometimes you may be asked to list out the event of getting a number which is even, the event of getting a number prime. So you can take, in all those cases, you can take even from this set, prime from this set. Depending on the question, you can list out the events, right? So this is the second example. Let me add one more example, then we proceed to the next definitions. Okay, in the third example, write numbers 1 up to 10 on 10 identical cards. On 10 identical cards. So write numbers 1 up to 10 on 10 identical cards and randomly take one card. Randomly take one card from the cards. From the cards. Okay, this is the activity. Then, what is the sample space in this activity? What is the sample space? The second one is write the event of getting. Write the event of getting an odd number. Similarly, write the events of getting a prime number. Write the events of getting a prime number. A prime number. The first one is write the event of getting a number divisible by 2 and 3. Well, here in the third example, there is an activity. Here, the activity is we write a number 1 to 10 on 10 identical cards. Why the need to make it identical? Because the experiment will not be biased, okay? So the cards should be identical. So after writing the numbers 1 up to 10, we are asked to randomly take one card from the cards, right? So in this activity, we are asked to describe the sample space. So what is the sample space in this activity? The second one is, what is the event of getting an odd number from this activity? The third, the event of getting prime number. And the last one is the event of getting a number divisible by 2 and 3. Okay, so in this activity, the activity is writing a number 1 up to 10 and randomly pick a numbers from these cards. Okay, so in this experiment, you are asked to describe the sample space. I hope you said the sample space is a set containing numbers 1 up to 10. Okay, so let's see the answer. The answer for A part is, it asks about sample space. So our sample space contains numbers 1 up to 10. 1, 2, 3, 4, and so on. And the last number will be 10. Because all the possibilities in that random taking will be numbers either 1 or 2 up to 10. You cannot have a chance to pick 11 or 12 because we don't have a number 11 in the experiment. So these are the possibilities that you can pick. So that is the sample space. Okay, so this is the answer for A part. When we see the B part, in B, we are asked to list the events of getting an odd number from these cards. So the event in this case is 1, 3, 5, 7, 9. We have only these odd numbers in this set. Okay, if you completely list out all the elements in S, you can observe the odd numbers 1, 3, 5, 7, 9. Okay, you don't have any other option. The C case is, in C, you are asked to list out the events of getting prime numbers. So you all know that prime numbers are numbers which are divisible by 1 and the number itself. Okay, we are considering the positive factors. Okay, all prime numbers have only two positive factors, the number itself and 1. So based on this, the event of getting a prime number in this experiment is a set E containing 2, 3, 4 is not a prime number. You can take 5, then 7. Okay, we have only these odd numbers in this set. Okay, there is no other prime number. So you need to list out all the prime numbers as an event for C case. Okay, and lastly, we are asked to list out the events of getting a number divisible by 2 and 3. Okay, so to answer the statement or the question in D, you need to list out all the numbers. In fact, this is finite and very small, so that you can list out all the numbers and observe which of these numbers are divisible by 2 and 3. Well, from numbers 1 up to 10, we have only one number which is divisible by 2 and 3. And that number is 6. Okay? So the event will be a set containing one element, which is 6. Okay? So this is the answer. I hope you said this thing. Okay? So this is the answer for example 3. Now let's proceed to the next definition in the theory of probability. Earlier, we have seen 3 definitions of terms, okay? The first one was about experiment. The second one was about sample space and events, okay? So we have seen what this definition of terms looks like, and we used examples to clarify the definitions. Well, the fourth definition is about, definition 4 is about composition of events. Definition 4, 2 or more events are said to be equally likely if the events have equal chance to occur in the experiment. Well, so the first definition, this definition is very important, and we will use this concept in determining the probability of some events. Okay, so this definition tells us 2 or more events are said to be equally likely if they have equal chance to occur in the experiment. Okay, so this is the fourth definition, and the fifth definition is about certain events. Okay, definition 5 is about certain events. So the fifth definition is about certain events. Okay, here an event is said to be certain if we are sure it occurs at any performance of the experiment. Okay? For example, the event of getting a number less than 7 in throwing a die is a certain event, because we are sure that we obtain a number less than 7 in any of the experiment in throwing a die. Okay, so such an event is called certain event. Okay, an event which is sure to occur in the experiment is called certain event. Well, the next one is about the definition of the opposite of certain event. An event which cannot occur at any performance is called impossible event, which is completely opposite to the definition 5. Okay, so the definition 5, or the next definition, is about impossible event. Okay, definition 6 is about impossible event. As its name indicates, an event which cannot occur at any performance is called impossible event. For example, if you take the previous example, which was about throwing a die. In throwing a die, finding a number which is greater than 6 is impossible. Why it is impossible? In that experiment, you cannot find any number which is bigger than 6. Okay? For example, you may be asked to determine the event of getting a number 7 or a number 8 or more. Okay? Such an event is called impossible event. Okay? So this is the 6th definition. We do have one more definition about the concept of probability. Let me write this definition first, then we will see one more definition in the theory of probability. Okay, so an event which cannot occur at any performance in an experiment is called impossible event. Okay, so this is the 6th definition that we have for today. There is one more definition, which is about generally the probability of an event. The probability of an event is the measure of a chance in which the event occurs in the experiment. Okay, so I will just repeat this concept in the next lesson. So generally today we have seen around 6 definitions. Each of these definitions are very helpful to understand the probability concept. And in the next period, we will see how we can calculate the probability of simple events. I hope you have learned a lot today. This is all for today. Thank you for watching.